Teleoperation systems could benefit from force sensory substitution when kinesthetic force feedback are too bulky or expensive, and when they cause instability by magnifying force feedback. We evaluate the performance of telemanipulation with force-controlled sensory substitution device by implementing magnified force feedback. The new force-controlled sensory substitution device was mounted on a Vinci Research Kit DVRK manipulator for force sensory substitution experiment, and it was removed for kinesthetic force feedback experiment. A 6-axis force sensor was mounted on the operation platform to measure applied force. The motion-scaled position of the master tool manipulator was applied as the desired position for the patient side manipulator. Forces were then scaled by a factor and transformed back to the frame of the master side manipulator to provide kinesthetic force feedback via either the master manipulator or the force sensory substitution. This movie is the example for the step of the peg transfer task by sensory substitution with 10 times force scale. Participant shift the soft green peg from the right end pole to each subsequent pole on the left. This slide shows an example for the result of peg transfer experiment. In a peg transfer task, 10 times magnified force sensory substitution feedback minimize applied force. This slide shows an improvement rate of 2 times magnified kinesthetic force feedback and 10 times magnified sensory substitution feedback in all 4 metrics. In all 4 metrics, there was no statistically significant difference. Magnified force feedback using sensory substitution can decrease applied forces similarly to kinesthetic force feedback. We summarize our results as shown here and look forward to seeing you at the interactive session.